mutex is just going to straight, not inline, but it's just going to be a wrapper around the value that we're interested in. But arc is going to point to something. So if I were to, like if instead of making an array of node pointers, I made an array of nodes, meaning that I wouldn't have to follow pointers all the time, and I could reduce my cache misses, then I would not be able to do that in Rust, as far as I'm aware. Technically not able to do that in Rust this way, but arc and mutex are both part of the standard library instead of being baked into the language. So, you know, if you don't like the way something is, you're always free to rewrite it. But
don't tell Max that.
Alright. So that is, yeah, so that's how you can avoid, so the restriction that you can mutate a variable, XOR you can alias a variable, is how Rust can get rid of all these, just entire classes of memory errors. So, memory leaks I mentioned earlier can be cleared up because you're never dealing with pointers. Sort of, you can declare unsafe code and you can deal with pointers that way, but you're not supposed to unless you absolutely have to. I've never had to. So the way that you deal with memory on a heap is by calling, you know, the box syntax. The box syntax takes care of freeing all your memory as soon as it goes out of scope. So so you never have any memory leaks, you never have any memory errors because you've tried to like free something twice. It takes care of all that for you without a garbage collector. So there's almost no runtime.
Sweet.
Yeah.
I hate that it's not part of the language. I kind of don't like the syntax compared to the Swift counterpart, where it does all the same things, but there's no runtime. But no runtime is pretty sweet, so
Yeah, I
I
mean,
guess I'll have to get used to it.
they have different targets, definitely. Like Rust is more intended to run on like embedded hardware or places where like performance is extremely important. But like Rust and Swift both have like independently come to similar design choices.
Yeah, I've noticed a lot of things you said was implemented this in Swift in an easier to understand way, but with a lot of overhead. A lot. One of your first things, I don't remember what it was, one of the first things you said was like, oh, we can do that in Swift, except that like we're totally in trouble if like we actually want it to be performant.
Does Swift, do you know, does it compile to like its own intermediate representation before going to LVM? Okay.
It's not C at all.
Okay.
Yeah.
Rust does the same thing, and I read something a while ago that was like, hey, this is definitely the right choice because two different programming languages independently decided that it was the right choice.
Yeah, exactly. That's great.
And so then, so Rust also eliminates use after freeze by having the borrow checker like magically make sure that no references ever can outlive what they point to. So, of course, in C you can malloc something and then you can free it and then you can still use it, or you can omit freeing it and then you would have another error there. You know, so that's a problem that you won't always notice immediately, right? It's a problem that you're going to have like an unfortunate time debugging, which Rust can, you know, tell you about. Which Rust will refuse to compile unless it can prove that you're not doing that. And then, so of course, data races it can prevent, and it also prevents iterator invalidation, which is it prevents for the same reason that it prevents the others, but iterator invalidation doesn't really fall in the same category as data races or use after freeze.
It's just a pain in the ass.
Yeah.
Because you have to use iterators a lot in Rust, right?
Yeah. So in Rust, like there are lots of things that you can do that would technically be safe that Rust doesn't let you do. And so like there is a price to a lot of this, but so for example, if you're iterating through a vector or something that is you know unsorted and you try to push or pop from it, then in many languages that'll often be fine, but it'll sometimes you know it'll sometimes be really unfortunate if you push into a vector as you're iterating through it, because memory is copied somewhere else, or like if you're in a tree or something like that, then it gives you unexpected results. Rust, because you are iterating through something, that equates to aliasing to it, and so you can't modify it at the same time while you're iterating through something. So the same rules prevent iterator invalidation.
Oh, that's really awesome. So in your equivalent to a for loop in Rust, you can't modify it.
Right. So
I mean, you shouldn't do that, but.
yeah.
Well,
So,
maybe you might.
so there are. So it can be irritating. Like there are just some things in Rust that are like kind of a pain in the ass to screw around with.
So you would just use map instead, right?
Well, so map has a similar issue where even if you can run into iterator invalidation, which I'm not sure if you can, it's still like you're still aliasing it. If you're aliasing to it, then you can't modify it. So instead, a lot of the more common data structures just have structures in place where you can, like when you're dealing with map, you like get a reference to an entry, and then you can check out the entry, and then you can like modify that in place because it's, I don't know. So it's like more complicated things that like are harder than they necessarily should be, but they're just they're collateral. Yeah. So like there isn't really anything that. So one of the things that I've talked about, they're not things that Rust's competitors or like C++ couldn't do. They're things that Rust doesn't let you do because it can't prove that they are the right thing to do, which is interesting. It's kind of it's an interesting trade-off. You kind of manage to get speed and safety at the same time, which I don't like. Very few languages really let you do, but it's at the trade-off of like you can't necessarily write it the way you want to write it. I've heard a couple people just get really frustrated with Rust and give it up immediately because like the first thing that they tried to write was like a hash map implementation or like a graph or something like that would be kind of interesting and not super complicated in C++, but like would be a nightmare to implement, or is a nightmare to implement in Rust because like if you imagine a graph, everything needs to have a reference to everything else. So it's like really unclear that the ownership system would work. If like you can have a child that points to its parent and a parent that points to the child, like you know it gets difficult to understand which what owns what, or and just like wrapping everything in a reference counter gets messy and limits functionality.
Yeah, that'd be awful.
Yeah. So like what you're just supposed to do is